We'll get started. Thank you. Thank you everyone for joining today's webinar. Uh, we're very excited to have our guest today, Carole Tonello Sampson with Hiperbaric. She was one of the Red Circle honorees from the Women's Alliance Network. So we're just very excited to have her speak on the technology of high pressure processing. We also have our host extraordinaire, Matt Hartman from Blendtec. He's a senior account manager for them, and he's also the chair of our technology network. He'll be moderating today's webinar. Introduce and pass it on to our moderator, Matt Hartman.
Thank you, Christine. So we have a little bit of announcements we need to go over. So I want to get a shameless plug-in for the annual conference coming up on March 4th through 6th in Carlsbad, California. I'd love to see as many people there as possible and more contributors to the technology network going forward with this year. So please, if you can make it, we sure love to have as many people as possible. And then the Women's Alliance has a webinar coming up shortly in March. It's Your Attention, the Secret Ingredients of Successful Leaders webinar coming up on March 12th at 1 p.m. to 2 p.m. Eastern Time. So with that, let's go ahead and get started. So for today, as Christine said, we have Carole Tonello Sampson from Hiperbaric. She's a commercial and applications director for Hiperbaric, the world leader in designing, manufacturing, and marketing high-pressure processing industrial machines for the food industry. She is also a member of the company's board of directors. And prior to Hiperbaric, Tonello Sampson worked for HPP R&D companies in France as an industrial researcher with emphasis in HPP for food. After her undergraduate studies in biochemistry and food technology in France, she obtained a PhD in food science on the effects of HPP on the inactivation of microorganisms. Well, Carole comes to us from north of Madrid this afternoon. It's approximately 8 p.m. there. So thank you for joining us into your evening. So my first question as we went through this and we were talking about it, the first question that came to my mind, Carole, is how did you get yourself into HPP, into high pressure processing?
Okay, so thank you, Matt, for the nice introduction. Thank you, Christine, for the webinar, for all the organization. Well, how I started in HPP, I started with my PhD in 1992. There was an interest for this new technology because the first products were launched, first HPP products were launched in 1990 in Japan. Jams and juices were launched, and so there was an interest in Europe, also in North America, to understand the technology, and so I could start a PhD on this subject. As the main interest of this technology is to kill microorganisms. As I was microbiologist, I started with that, and I'm still here, so that's great.
Whenever you were going down the road of HPP, and I think you made a comment about it started in Japan a few seconds ago, was there a particular problem that they were trying to solve with this technology?
The interesting point was that in Japan, they were looking for a non-thermal technology to avoid the problem that can cause heat processing, so change of color, texture. Well, they wanted to find something fresher to be able to bring to the market fresher products, but with a non-thermal technology. And we know that concerning killing microorganisms, the most efficient technology is irradiation, but in Japan, irradiation is prohibited for food because during the Second World War, they had, since then they are really against irradiation, and it's prohibited for food. This is why they invested in a very large R&D public program, and they could develop the first commercial products. Nevertheless, the technology was known since the first publication on food were from an American researcher, I don't know how to pronounce, sorry, I pronounce it Spanish, so it should be it. And he published the extension of shelf life of milk in 1899, so more than 1 century ago. At this time, the technology, the machines were really at laboratory scale, not reliable, so it was not possible 1 century ago to have industrial high pressure machines. Now it's possible, and of course the technology has grown a lot.
So clearly things must have changed over the last century with it, but do you feel that the principles are still the same?
Principles, that's great. Principles are exactly the same. If you want, I can show my screen, and I have a few slides.
Okay, please.
Just to show you. So the principle is quite simple. Oops, sorry about that. I hope you can see my screen, and the high pressure processing is to apply to food very high pressure transmitted by water. Those pressure are around 6 tons per square centimeter. It's very heavy. It's like to have 3 elephants on a dime, on a small coin. And with this pressure,
could you say it again, Carole, just to make sure? Did you say 3 elephants?
Yeah. 3 elephants of 5 tons. If they are, the weight of 15 tons on a dime, 10 cents of dollars. This is the pressure we have on the product. The thing is, the pressure is transmitted by water, so it's the pressure like the one we have in the sea. Well, much more pressure than the one we can have in the sea, in the deepest ocean, 6 times more than the pressure we can have in the deepest ocean, in the Mariana Trench. But this pressure is applied
6 times. 6 times the pressure in the Marianas Trench.
Yes, that's it. But this pressure is transmitted by water, so it's the same pressure everywhere. It's not like in a press where the pressure is what we call static. So it's the product would be completely smashed, but it's a pressure going everywhere. So the volume of the food decrease of about 15, 20, 25%, and after depressurization, it comes back. This is very nice because the pressure is like, well, it's a little bit similar to the temperature, except that the molecules goes closer with the pressure, and with the temperature, it is the opposite effect. When you increase the temperature, in general, the molecules are more separated, and with the pressure, it's completely the opposite. So we have with the high pressure, we have things effect similar to the temperature, like killing microorganisms. But on the other side, we have other properties or effects very different. So this is really, for me, it has been always very scientifically very interesting to study. This is what I like.
I'm sure it's fascinating. I know after I started getting involved with this, as I walk through the store, I go to a Kroger, and whenever I walk through the store, I become more aware of what looks like products that have been HPP'd. But my question to you is that whenever it does kill the microorganisms and the pathogens, why do you still have to refrigerate it?
Well, because in this sense, the process is different from heat processing, because we do not inactivate enzymes, or we inactivate the enzymes really partially. This is why we have to keep refrigerated, because we have to avoid enzymatic oxidation, for example, of food. And on the other hand, we have we do not inactivate spores, microbial spores, so it's not a sterilization, it's a pasteurization. And so the shelf life is much larger, much longer for pasteurized food if you keep it in the fridge. So for both things, I would say almost all the food processed under pressure are stored after pressurization in chill temperature. So I'm sorry.
No, I see.
Yes?
No, that makes perfect sense then of why you still need to refrigerate it.
Yes. It's
Matt
between.
and sorry,
Yes.
Matt and Carole, we do have a question from Greg, and I was wondering the same thing. Okay, so what technology or instrument, or is there a sensing mechanism that is used to measure the high hydrostatic pressure in the chamber, or is that all built
Yes.
in?
Mm-hmm. So we measure the pressure with two pressure transducer. So also one properties of the pressure which is different from the heat is that the pressure is the same in the product. It's the same in all the processing chamber, and going up to the processing chamber we have high pressure pipes, and because the pressurized water come from the intensifier inside the chambers through pipes, and on the pipes we connect two pressure transducer. Those pressure transducer work with it's a metallic they have a metallic part that under pressure move a little bit, and we measure the movements. This is transmitted electrically to an electronic device that can evaluate with the shape modification of this metallic membrane under pressure what is the pressure applied. So we have two on the machine. We have two certified high pressure transducer measuring the pressure continuously, and then we have also other devices to check, but with a little bit less precision, the pressure. So we measure the pressure in the intensifier, and also we measure the elongation of the yoke. The machine is made with a chamber with wedge, plugs, and a big yoke, which is the frame that maintain the system, that maintain the plug close to the vessel, because the plugs are not with a screw. They are we have only a seal, and so during the pressurization, the yoke have a slight elongation of few millimeters, and we measure that. I mean, the yoke is a very heavy part. For the biggest machine, the yoke is 50 tons. And so it's a really big piece of metal to be able to maintain this big pressure. And so we measure the elongation of the machine. So we have different devices.
Whenever you're talking about the intensifier, could you elaborate a little bit more about how does that work?
So it's quite, I would say, simple. We have a motor that moves oil pump. We pressurize oil up to around 200 bars. So this should be in PSI. We have to multiply 3,000 PSI, more or less. And the pressurized oil push a big piston, and this big piston push a small piston which push the water. So it's an electro-hydraulic intensifier. Mm-hmm. So we have the oil piston, we have oil coming by one way, pushing the piston, and then coming by the other way, pushing the piston. So with the movement of the oil and then water piston, we intensify the pressure of the water. In our intensifier, the multiplication factor is 35. So when we have 200 bars of oil pressure, we have 7,000 bar of 80 almost 100,000 psi pressure in for the water. So this is how we create the pressure. So we send more water in the same volume of the chamber with a pump.
Okay, fascinating. So I guess my next question was, you went back, there were always two sensors. You always talked two pressure transducers. Could you elaborate on why that is?
So the pressure transducer just check the pressure, as the pressure is the same in all over the volume of the chamber, and it's the pressure also inside the product. Mm-hmm. The beauty also of the pressure is that pressure is a wave, so it's everywhere the same pressure. So in a fluid, the pressure is the same everywhere. So we measure from the pipe arriving to the chamber. We measure the pressure. We have two pressure transducer in case one fail, because really the pressure is the critical point. We don't want to be below the pressure we target, and we don't want to be, for safety reason, over.
For sure, that makes so much sense. So one thing one thing I kind of grabbed my attention, I did go through the store, is it looks like, after you explained to me what the packaging is, that you see a lot of guacamole.
Yes, really. Well, we have different type of products we can process under pressure, from vegetable products like guacamole, juices, beverage, meat, seafood. Well, we have a lot, but really the consolidated trends in HPP are, that's true, Matt, are guacamole. You can see on the right side some well-known brands in United States, some of our customers, and also we sell about, I would say, 1/3 of our machine in the last year we've sold to juice manufacturer like Evolution or Suja in the US. But this is really the products we more process under pressure. In the case of the guacamole,
why would these juice companies go down that road? Because it seems like doing a high pressure processing would be more expensive over maybe a retort type process. Why would a company even go down that road?
Because this is a juice like the fresh juice you can squeeze at home. Well, nevertheless, well, the problem is that when it's almost impossible to squeeze, for example, green juices at home, or you have really a puree, it's quite difficult to have a fresh juice. With HPP, you keep the freshness, so you keep the enzyme, you keep the color, you keep the flavor, but you increase the shelf life. So this can be done industrially, and we can extend the shelf life from few weeks to few months, with really a quality very, very similar to fresh. So this is to be fresher. I mean, the pasteurized juice are good, but HPP juice are much fresher. That's the things. Concerning the guacamole, we have two benefits. We inactivate, at least partially, but it's enough, the polyphenol oxidase, so the guacamole does not turn brown. So it's better than if it would be fresh. Mm-hmm. And also for guacamole, we inactivate spoilage microorganisms and pathogens, and we can extend the shelf life from few weeks to few months, depending a bit the pH, the recipe, and so you can have a fresh like guacamole, but in a convenient format with a much longer shelf life. So that's really, it's the technology is used to have a safer product and a fresher one. For plant-based product is to be much fresher, and for meat products like the one you can see here, because Hormel Group is the company having more HPP machine. For example, they have the brand, of course, Hormel Natural Choice, but they have also Columbus for meat products, sliced meat products. In this case, this is mainly in meat business. This is mainly for safety, because the products don't have to be fresh. Or in the case of Applegates, this is also for safety, because this company, they want to remove all the chemical preservatives, and so the shelf life could be very short.
Right.
And or they could have problem with without HPP, they could have contamination with some pathogens. So if they want to achieve the safety targets in activating microorganisms, they have to use HPP mainly.
So whenever you're given a product to, let's say, from Applegate or Columbus, and you start doing trials in your labs, is there? Could you tell me a little about maybe like the curve, like the pressurization curves? Does that matter? What are some of the critical parameters you have to look for other than just pressure? Is there other things that get involved with that to hit the kill step that you're looking for?
Well, I would say the two main parameters are pressure and time. And concerning, so this is concerning I would say the machine. Saying that we have almost, I would say, half of our customer processing at the maximum pressure of the machine, which is 87,000 psi, 6,000 bar. So then we cannot go over because the machine, this is the maximum pressure of the machine. So you can play with the time. The temperature, it's chill or room temperature, the processing time, the processing temperature, so it's not a big point. There is no influence. This is not really a critical parameter. But concerning the recipe, the critical parameter are the pH. Lower, it's better, because we have a synergy between low pH and high pressure concerning killing microorganisms, or presence of antimicrobial substances. So and we have also another very important parameter, which is water activity. So more water in the products, better would work the high pressure process concerning killing microorganisms. So, for example, the processing of the Columbus sausages, dry cured sausages, it's much longer than the process of the guacamole. Could be 6 minutes, 6,000 bar, or 87,000 psi, and the guacamole would be 3 minutes. So we are playing around this type of range of time and pressure. And
so once you get to the 6,000 bars, you're saying it's the time at 6,000 bars.
Yes.
And then that time is correlated to, from what I heard you say, was the pH and the water activity of what you're trying to HPP.
You're right.
Interesting.
Yes. So so when a customer wants to develop a product, he needs to perform validation studies of shelf life, and of course we can give advices on what should be the parameter that would work with the products. We have now hundreds of products processed all over the world, so we have quite a good experience. But I would say not every day, but I would say every month we have companies coming and trying to develop new products. So that's in this case we had to study the parameters of the products, and we have to do some trials. So the trials are, I mean, checking the impact of on packaging, and also inactivation of microorganisms, and evaluating the shelf life.
Is that how much time do you see people coming to you and saying, we already have a package, and here we want to HPP this package we already have? Or do they come to you and go, hey, we have this product, we have this sausage, and what kind of package do we need if we want to go down the HPP road?
Well, the package is in the impact technology. When I mean currently all the machine in the world work with the product package. So in this case, the package needs to be flexible and need to resist to water, because the products is in contact of the water during the pressurization. So in general, it's plastic. I mean, it's quite easy to use, I would say, a regular plastic that you can easily find. So it's just trying. In some cases, we could have delamination, but it's not so difficult to find. So we have different type of. We can use vacuum pack. We can use trays, pouch. What we have to avoid is a package with a lot of gas, because the gas is completely compressed under pressure, and so the shape of the package would be really smashed, and at the depressurization, in some cases, it doesn't come back really very well, so can be damaged. So we try to reduce as much as possible the modified atmosphere we have in the package. The best is skin package or vacuum package, but it's I mean, it could be only to develop the products and start producing. It can take from, we had some company, it could take longer depending the rhythm they go, but normally in few months, I would say you can have the products on the market. Of course, you need to do the proper validation to be sure that to the end of the shelf life you have no problem. And in the US, for example, for juices, you need to check that your process inactivate 5 logs of the 3 main pathogens. But this is, I would say, in minimum, I would say half a year. That's
okay.
You could do it. So, and then you would need, I would say, another half a year to order HPP machine and to have it installed and delivered. Or you can use tolling manufacturers. There are many of them in the US, and they offer the service. And so you pay as you go. So you can go with your products and your validation studies to be able to show that the products processed under pressure would be processed in the good condition to the food safety authorities, and then you can start commercializing. So I would say 1 year.
1 year.
1 year. Yeah.
1 year.
Yes.
I'm gonna go down that road of validation because that's really interesting. I'm an automation guy from the beginning of my career, and one thing I was always infatuated with was data, and getting as much data out of the process as possible, just to understand how the equipment's behaving and for optimization. What do you do? What do you folks do with data, and how does that get wrapped into the validation processes that you get involved with your customer?
Mm-hmm. Well, really, there is really, I would say, no validation of the machine, because the machine is we just have to check we reach the pressure and we measure the time. So this is not very complex. The validation is on the products itself. So the products need to have the customer need to have a stable pH. Or to make all the production with more or less the same pH. I would say we have a slide, or he has to use the products with the highest pH, the more neutral pH, the less acidic one, and the products with the lower water activity. So in this case, he can do categories, taking the worst products, or the products where we expect that we would have less microbial inactivation, so lower water activity and higher pH, and by categories of products. For example, for juices, one citrus, the other one green juices, and the other one berries, for example, something like that. And and in laboratories you can inoculate the three main pathogen, or the pertinent pathogens, which are in general E. coli, Salmonella, and Listeria, and see if you process under pressure, and then you see what is the log reduction. And you check if you, for example, for meat, in general, it's 3 log reduction. For juices in the US, it's 5. And then, of course, you can also, without inoculation, check if you will get the shelf life you want with the spoilage microorganisms. So this is what is the validation for the HPP product.
Very good. So do you see a trend whenever people come to you of what sort of problems they're trying to solve? Is there a trend there?
I would say that with the slide I have here, you have people wanted really to solve problem of Listeria, that the products like the products of Columbus, the dry cured meats, when it dries during a month, you can always have few Listeria inside. So if you want to be Listeria free, you need to find a solution. So heat process is not possible because it's dry cured, need to stay raw. If you cook, it's not the same product. So, or it's really to reach the safety objective, to inactivate some possibly presence of pathogens, or in the case of other products like Applegates, is you want to remove all the chemical preservative, and then you need to stabilize, and you need to have a safe product. And in the case of the guacamole or the juice, you want to keep the color, you want to keep the freshness, you cannot heat process, and you want to stabilize. So you want really to keep the freshness. I mean, in the case of the freshness of the plant-based product, I would say for meat it's more safety or removing chemical preservative, and for the plant-based products is to increase the shelf life, and of course inactivate the pathogen to keep the freshness of the plant-based product.
Could we go and show that video that you had? I think that video helps show a little bit about what we're talking about here. How heavy is one of these pieces of equipment?
Okay, so for the juices, for the juices we have developed a new machine, the bulk, that process in bulk the juices, because the biggest juice producer are in general really reluctant to load and unload in the machine the bottles.
Okay.
Because it's they are used to go from one tank to the other and then to bottle. So we developed the bulk machine. So you can see a really short video, 1 minute video of the machine. So that's should start.
Before I start the video, Carole, there was, speaking of juice, Ivana had a question. Is there
Yes.
a maximum bricks? I had to look that up. Sugar content, I think, that HPP is effective for juice.
It's always effective for juice, because it's only when we reach 50 bricks, which is not juice, it's really concentrated, it's puree. Then this is when we start to see a much lower inactivation of microorganisms. So really the water activity, it's much more problem in dry cured meat or in solid products. For juices, I mean, if it's liquid, even if we have done trials, for example, with the juice full of chia seed, so it's almost a gel, but it's still very high water activity, and we still inactivate microorganisms. We did those trials because we were afraid that perhaps with seeds we would change the parameter, and the inactivation will not be so high, and it was not the case. It was working very as if it would be the same juice but without the seeds.
Okay,
that's a great question, because going down that road, what sort of food gets damaged? what are bad applications?
Bad application, it's all the dry foods, so flour, paper, things or very highly concentrated purees. When you don't have water, because the water, so under pressure, the water pressurize the package, transmit the pressure, but the physical chemical effect on the microorganisms are also transmitted by water. If there is really few water in the products, the killing effect of the pressure is not the same. The product is protected by the low water activity.
Got it. Interesting. Were we able to queue up that video, Christine? Or
yep. I'll go ahead and start playing it.
Hiperbaric presents a breakthrough innovation, the Hiperbaric 525 bulk, a high-pressure processing machine for large production of beverages. This unique equipment is based on a totally new concept in which beverages are processed in bulk before bottling, delivering up to 5,000 litres per hour. With the new in-bulk machines, the total cost of ownership per litre will be cut by more than 50% compared to traditional HPP in-pack process. Energy and wear parts consumption is significantly diminished. Labour cost is drastically reduced. A single person can operate the Hiperbaric 525 bulk because no manual handling is needed. The Hiperbaric 525 bulk is the world's most cost-effective and productive equipment, reaching up to 5,000 litres per hour. To find out more about high-pressure processing, please visit us at hyperbaric.com.
That's a neat video, Carole. How big is that machine? What sort of footprint do you look for?
So it's quite big. The weight is 90 metric tons. So if you convert in elephants, I would say this is roughly 20 elephants. and this is 16-meter long, 5-meter large, and 5-meter 8. So this is a big piece of equipment. Yeah, sure. It's quite heavy. It's quite heavy. The first hyperbaric bulk, the machine you've seen on the video, has been installed at the end of last year nearby Paris, at 100 miles from Paris, and the factory where it is installed is beside a river, and they have to place big pillars in the floor to be able to withstand the weight. Normally with industrial floor, just reinforcing a bit, this is enough. But in their case, the soil it's really very weak, quite weak, and so they had to make quite to reinforce quite a lot. But we have installed big machine like that. I mean, at least 50 all over the world, and it's heavy, but it's not a big deal. It's a lot of concrete. That's all.
A lot of concrete for sure. If you want to do a trial, somebody came to you, where would you do a trial at?
So you can come, of course, you can come and visit us in Spain. We have, in North America, we have a pilot plant in Miami, Florida. And you can also visit some technical center, university having a pilot plant machine, like Cornell University, Nebraska University, in United States. In Europe, we have other customers. And there are much more laboratories that have small vessels where you can do trials. So that's not too difficult. And of course, we are very happy to receive the customer to make trials, just contacting us. And we have a lot of customer offering tolling manufacturing that open their door if you want just to test, just to see how is going the products. I mean, they are very happy. When you want to inoculate with pathogen microorganisms, then you have to go to laboratories or pilot plant that are not located in food factory, of course. But for the first trial, just to try and to check the quality and shelf life. I mean, they are, I think, between our machine and the machine of our colleagues, of our competitors, they should be in the United States around 100 machines. So, and all over the world, more than 500 machines are installed. We have almost 300.
Wow, that's impressive. So one thing, as we talk, and I see the comfort with which you talk on this subject. Could you talk a little bit about your rise within Hiperbaric, and how you've risen to the director level that you're at?
Okay. Yes. Well, so I'm not sure if you see me or if you see my screen, but in any case, well, I did my PhD and I started with on HPP, so that was really a goal for me in the life to work to develop this technology. And when I started with Hyperbaric, the company was building the second machine. So I'm here almost since the beginning, and that was really interesting for me to be between the customer, between the science with my PhD and also the engineering team to develop the technology. So I'm in this business with this technology for 28 years and 17 with Hyperbaric. This really has been, this is good. This is good to start from scratch and to grow with the company. So when I started, I was taking care of, I would say, sales and application with the general manager, and now we have I have a team of colleagues of almost 15 colleagues between application, sales, and so this has been a growth, and really it's like that. I mean, I would say it's like a passion, and you grow with, or I've grown with the company, so that was nice. I think what I prefer working is to, I define myself as creative. So being with a very working in a very innovative company for a new technology, I think this is nice because you can propose new ideas, you can test it, and you can see when they are good. Not all of them, of course, but when they are good, you can see their implementation, and this is really grateful. This is really what I like. So I was really I really enjoy the award I received, because I think that ladies can also be involved in, of course, in innovation, and can inspire all the, I would say, the companies, but we can be, I think the women, we can be as creative as men. I would not say more or less, or depending the people, but I think we can bring to the industry, we can bring ideas, and this helps, of course, collaborating with men. It's stupid to exclude anyone, but I think we can bring also perhaps in some cases a different point of view, and that's nice to be included, to participate. I really enjoyed that.
Very good. Do you have any lesson learned that, as the Red Circle honoree, do you have any lessons learned over your career that for men or for women to help inspire them to accelerate their career and learn from your successes and maybe even from your failures?
Well, I think you need to be really motivated, but by what I would say, you need to enjoy what you do. I would say, and to be engaged. I would say you don't have to be shy. You need to share your ideas, your critics, not to be, of course, offensive, but I think in this case it helps. And I would say my failure, it took me quite a lot to work in a team. So when I started with the company and the technical center I was working with before, I was alone, almost doing my work and trying to convince customer to explain the technology. And then it took me years to be able to build a team. But really now I really enjoy, because working with people that are better than you, I think this is the best also you can do, when you see that other brings good ideas. And this is really what I like. But it took me a while to change and to be as much as confident in my team or in my colleagues than I am, because I'm quite self-confident person. So I think this was previously, this was my failure. I have a lot of others, but the list could be perhaps too long for the webinar.
No, I mean, thank you for sharing those and being vulnerable and sharing. I love your passion that you bring, and I can tell just you love what you do. You're so engaged with this, and it's always wonderful to talk to people who just love what they do.
Yes, I think if you can find this is my advice to some new colleagues or young people we hire. When I see what the job they propose, we can propose them because we have limited position to offer. When I see they are not really pleased with that, honestly, in general, I said them, okay, if it's not if you don't feel really happy or comfortable, you are good. That's much better. You find something different that you would enjoy. I mean,
Right.
I would not doing a job you don't like. Well, I mean, it's a lot of time in a life. Working take a lot of time. So if you don't like what you do, that's I think that's not good.
No, yeah,
Your
you
life.
spend more time with your coworkers and your family. I
Yes.
know I do, and you're right, and that's why I love where I work. I love the people I work with, and I love my job. So, and I see that in you as well. So it's nice to see that. I think my last question I wanted to ask you, Carole, was we talked about juices, we talked about different products. Could you bring up that one graph?
Yeah, this one.
The growth trend. Yeah, whenever I saw that graph earlier, you see that inflection point in 2011. And so my question is, as we're approaching 2019 and going further, do you see another inflection point that's going to take that curve up even higher in the HPP world?
Well, I think the 2011 change of the curve was due to really the development of bigger machine from us and from our colleague from other brands, because we launched in 2008, 2009 bigger machines, so giving a higher production and a lower cost per kilo, processing cost per kilo. So
okay.
That was the first thing. And then we started, especially in the United States, with juice. So our first installation was in 2009, was Evolution Fresh. And then Evolution Fresh was purchased by Starbucks in 2011, and then Starbucks invested in several more machines, and then Suja and other brand that started, and really the juice was the big growth. For the coming years, what we see concerning products is we see baby food growing, because over processed products are not really healthy. So sterilized baby foods, okay, this is safe from a microbial point of view, but this is not really I would really healthy, because it's really, I would say, it's not minimally processed, it's over processed. So we see more and more baby foods, and we have a nice new application that we see it has started last year and the year before, really growing. It's the fresh pet food. So this is for the coming year.
Fantastic. Would you mind, if you don't mind, Carole, being a little vulnerable here and telling that story you shared with Christine whenever we first met?
Yeah, perhaps I don't remember. It was perhaps 6 or 7 years ago. I was visiting in United States a tolling manufacturer having HPP machine and giving the service. And then I was going through the factory and seeing the pallets of the products that they were processing. And I had a look, and I saw on one pouch, there was the face of a dog. And I thought, so I was in United States, I thought, they eat here dog meat? And I was like, that's strange. And then I realized, I said, no, that's impossible. That should be pet food. And for me, the technology was for premium, so for human food, premium food. And I was like, pet food? I can't believe that. But on the only other possibility was dog food, and I said, no, if I would be in China perhaps, or in Asia somewhere, but in United States for sure, dog meat, this is not possible. So my first idea was dog meat in United States. What's that? And it was pet food. So it started with I would say 5 or 6 years ago, perhaps, and it's going up. It's going up because the pet food is over processed, because it's sterile. It has a lot of different ingredients, or it's dry, or it's sterilized. And the nutritional quality is not like if it would be fresh. So more and more people purchase fresh raw. It's mainly meat, could be mixed with meat and cereals or vegetables, and they prefer to give fresh product to their pet to improve their health. Mm-hmm. So this is the growing business. And perhaps in the future, perhaps with the bulk machine, I hope that we will develop the process of other, I would say, beverages. One could be beer. This is one of our hope in Hyperbaric, and because beer, it's the craft beer, the good beer, have to be processed and have to be pasteurized, but it decreases the quality, and then have to be bottled or in can or in glass, and this is not possible to process in an impact machine. So, and the other one, another dream we have, but this would need to change the regulation in United States, would be to process the raw milk, to have a cold pasteurized milk. So that would be nice. And
wow,
we have a customer that wants to develop that in Europe in this year. Hopefully, is doing all the validation studies. So perhaps this year or next year, this will be we will have milk, HPP milk. There is one brand commercializing milk processed under pressure, but in pack. in the processing in the bottle in Australia. So that's we have a lot of products that could go up, and we think that offering in pack and in bulk would help to grow the business in general.
That's so exciting. It's so exciting to hear what that future looks like for you folks. And I look forward to walking in the grocery store and seeing some of those products that we're talking about as they start to become commercialized. So yeah, I think that's trying to wrap things up here. Carole, is there anything last things you want to close with? Any last little nuggets you want to pass on to the viewers?
I would say no, just showing you the picture of the awards. So of the red circle, and with my colleagues, with my colleagues of Miami, and my two colleagues Ignacio and Andres working in Spain. So if we have to wrap up, for me this is the last slide.
Awesome, that's a great picture. Well, thank you so much, Carole. Christine, anything you'd like to add?
Just folks, look for the follow-up email with the recording, and please fill out the survey. Both of you, thank you so much. This was such a fun discussion, and I'll probably be listening to the recording later again.
Wonderful.
Okay, thank you very much to Christine and Matt. This was a good moment, great moment with you. Thank you so much.
Carole, thank you so much for being with us today. I know it's your evening, so go enjoy your dinner.
Thank you. Have a good afternoon.
Take care.